बुक जो कब
Okay, I think we can start. Okay, so last class I think we covered array list topics, right? And we started loops concept, right? Today's topics. So we'll go through the collections, remaining collections. Already we started array list, right? So array list we completed. So today we will see HashSet, TreeSet, HashMap. If time permits, we'll see introduction to tree map. Okay, and we'll solve few problems based on that. So this is our today's agenda. Okay. So in the last session, just to recollect what we did, we created a class student, right? And we created the constructor. So see here. So it's a parameterized constructor where we created two parameters and we initialize the variables, right? Here we pass the two parameters to initialize them. Then after initializing, we added those parameters to the array list, that is ST. Suppose here, if I don't want to initialize the parameter, both the parameters, that is name and age, and if I want to initialize only the name, that also is possible. Here what you can see, I have created an empty object of student, that is S3. I've initialized to null. Then I'm calling S3 dot set name. So this function I'm calling set name function. So how will you create a set name? Alt insert, if you press, you will get a setter method. Already set name is there. Okay, so you can see this function set name. So if I want to initialize only the name, I'm calling is 3 dot set name with that player name, right? Then for printing, here I'm printing only the name of the student and I mean the name of the player. And here if I want to display all the player details, right? For that I'm calling the object of array list, where internally it is calling toString method. Inside that we are printing name and age both here. So we can customize our output as and when required. And if I want to print only this, because this particular player doesn't have the age details, so I'm printing only that name. So if I print, you can see. So what we are getting, can't invoke S3 because it is null, right? So for that, so what is that error here? we have to create a empty parameterized constructor. So I'm creating the empty parameterized constructor. Then I'm initializing only that player name. Okay, so I'll print only that player name. See here. So you can customize what we want to initialize based on whatever the parameterized constructor or a default constructor. So here I'm not doing anything. I'm just creating the constructor because here I'm creating the empty object without initializing. Then I'm initializing through the setter method. So this is called as setter method. So this is what we discussed in the last session. So I told you the importance of toString method. So internally it converts the hash object into the respective data type. So without this toString, you will be printing the hash value. This is the basics about array list, how to combine the array list with the user defined classes using setter method, getter method, and constructors. So you'll be solving a lot of such problems in future. So you should have a clarity on what object you are creating. If you get error, how to overcome that, what constructor you have to call, that clarity you should have, right? So continuing with our next topic. So let us see some of the basics about HashSet. So HashSet I already introduced and we solved one problem last session based on distinct element, right? So using HashSet. So today we'll see what else we can do using HashSet and what are the supported methods. So we should have a complete understanding on, right? What and all we can do using HashSet, right? That clarity we should have. So let us create our main method, right? So just like array list, how to create the HashSet. So we have to use this collection framework called as HashSet, H capital, set S capital. Suppose if I want to create a hash set of integer, I have to use a wrapper class integer. So let us give the name for the object of the hash set1. Then I'm creating the hash set using new hash set. So we are allocating the memory for that object. So just like array list, how will you add the elements using add method? Let us add some values to it. Original values, displaying the asset content, right? So what we need to call the object reference of that particular hash. What is that you are observing here? Can anyone tell me? Context in the comment line and chat box. So how we are printing the hash set data? Is it ordered or unordered? Right? So the main difference between hash set and array list is hash set is unordered collection. Ordered collection. That means the output order is not guaranteed, right? So though I've inserted 100 first, 30 second, 50 and 10 in the end, but you see the output order is different, totally different. So this is not going to be guaranteed because HashSet is an unordered collection, whereas array list is an ordered collection. So this is the main difference between your array list and HashSet. And performance wise, HashSet is better compared to array list, performance wise, right? So similarly, so in the last session we saw array list we can sort using collection dot sort, right? So collections dot sort, we can pass the array list object, right? But you can see in the HashSet, if I want to sort the content of HashSet, so what is the problem here? So you can see the required type is list provided HashSet. So this collections dot sort will work only on the list object. So it doesn't work on the HashSet. So this kind of small syntactical clarity we should have whenever we are doing the problem solving, because most of the time we don't know what is the error, why we are getting this error. So understanding the foundations of this collection framework is most important while before solving the any problems in any platform. So this is the main difference between array list and HashSet. So here HashSet won't support the collection dot sort, right? So this particular thing everyone should notice. So this support in HashSet. Okay. Can't sort HashSet directly using collections dot sort. Then what could be the alternative way, right? And similarly, reverse also won't work. You try collections dot, even this also won't work, right? So what is the alternative way? So the one of the ways to convert, convert HashSet to array and then sort. That is one possible way, right? So before sorting, we have to convert that HashSet into array and then try to sort. So how to convert? Next question is how to convert HashSet to array, right? That is the first question. So let us try to do that. So if I want to convert HashSet to array, first I need to create an object of integer array, right? Right. So new integer array. Then size I want to mention here because I don't know the size of the HashSet. So how will you find the size of the HashSet? By using the object reference of HashSet. So you can see it's already giving me the suggestion set1.size. So here I'm declaring the set1.size, which will help me to find the total number of elements in the HashSet. So here what I did is I created an integer array by taking the total length of the HashSet. Now our next step is convert our existing HashSet object into array, right? So for that, I have to use the object reference of HashSet. So what is our object reference? Set1, right? So the name of the object is set1 dot. Then there is an inbuilt library file to convert that HashSet into array, right? So two array I'm using here. So set1 dot to array, for which I will pass the parameter of this integer array. So what is that integer array? ARR, right? So you can see the specification of true array. So what is the parameter I have to pass? The array into which the elements of the set to be stored. So for everything, you will get a proper clarity whenever you highlight your cursor over that particular function. So the main thing that you need to observe is the parameters. What parameters we have to pass to that particular function, right? So this to array accepts the parameter array where this content of has set to be stored. So basically what we're doing is we are copying the content of set1 to array, right? And we are internally we're converting that has set into array, right? Alternatively, if you don't want to do this, there is one more way, so which I will tell you later on. Next, we'll try to sort these collections using collections framework, collection dot sort. Now I'll use ARR. the object reference is integer. So what we have to do is arrays dot, I have to use toString for which I have to pass ARR. Okay. No instance of type variable t exists so that integer confirm. Okay. So basically we have to convert this array into so try to sort directly. Then we'll try to print elements. So this is the alternative way to sort the content of asset. Right. So try to sort directly using collection sort. I think that also won't work. Collection dot sort. Okay. So as you can see, we can't directly sort using collection sort dot sort for the this particular instance, right? Passes the array whose string representation to data, basically. So there is no supported method to convert it into integer. So obviously, so this won't work. The only way is you can sort like this. So there are a lot of alternative ways to do that. Okay. Let us try to print them before sorting. I'm trying to print. Okay, so original content, and this is the sorted content. So in general, to sort the asset values directly, it is not possible. So we have to do this alternative approach. We have to convert them into array. This will add all the elements of asset to the array using toArray method. Then here I'm sorting that array using arrays.sort. Then we are printing. Again, directly if you print, you will get the hash object. You can see the output is in non-readable format because it is an integer format. So let's try one more approach. Here, since I use the wrapper class, To array won't accept this particular instance, because if you want to do this, this has to be a wrapper class. So it cannot be a normal integer array, right? So we have to use the integer wrapper class. So this won't actually store the set elements into array. So the only option is to use the integer array. I mean the integer wrapper. So for which the to array, if you see the specification here, you have to pass this array method. You can try to sort the asset content. Right. So there is one more way to print the HashSet content, which we use called as iterator. So this is very powerful tool. Generally, they use it in real time to display the collection data. So iterator is universal for all the collection data. Right. So basically, what does it do is it helps us to traverse the content of the collection framework universally. That means iterator can be applied on any collection. So we'll try to see how to do this. So before printing that, I will also tell you what is TreeSet, right? TreeSet concept. So which is similar to asset. Okay. So to create TreeSet, we have to use this TreeSet collection framework. Then for which I'll pass the integer wrapper class. The object name I'll give as TreeSet equal to new TreeSet. What I want to do is I've already created the hash set here, right? The object name is set1. So I want to convert that hash set into TreeSet. So what I'll do is in this bracket, I'll pass the object of hash set. So what happens at this line is our original hash set is getting converted into TreeSet, right? So let's try to print the element. So what is our object of TreeSet? TreeSet here. So I'm using the enhance for loop. So the data type is integer, so I'm using int here. Then here I'll print each object one by one. So let's see how we are getting the output. So I want to print all of them on the same line. So as you can observe, in using TreeSet, internally the data is already coming in the ascending order. Here using HashSet, I had to do all that mechanism to convert that into array, then uh, sort it based on to sort method. But that problem we are overcoming in using TreeSet. So the advantage with the TreeSet is it internally sorts the data, right? It internally sorts the data. I need not to worry about whether the data is an ascending order or not, right? So whenever we require the data to be arranged in their natural order, then we have to use TreeSet. And whenever we are not concerned about the ordering of the data, we can use the HashSet. But in general, again, compared to TreeSet, HashSet is better in terms of execution speed. HashSet is better because TreeSet consumes extra memory for maintaining the natural order, right? So I'll tell you in coming topics why does it do so when I start explaining more about TreeSet. But this is the most important point. So TreeSet maintains the data in the ascending order naturally, whereas HashSet gives you the random data, right? Now that we created the TreeSet and we also access the elements one by one. So there is another way to bring the data. Suppose I don't want to use this for loop. So what I'll do is I'll use the iterator object. So let me name the object name as IT. Okay. Then what is our object name of TreeSet? TSet, right? So that I will use TSet dot iterator. Okay. So here what we are doing is we are creating the iterator object. Okay, guys, just 2 minutes. I have some guests. Just be online. Yes, sorry for the delay. So, so where were we? We were creating the iterator object, right? So here, in order to use the iterator, so we have to use that package import java dot iterator. So without this package, we can't use this iterator class, right? The iterator, what I'm trying to do here is we are trying to print the elements of the tree set. So what is our tree set? What is that iterator object I created? IT, right? So IT dot has next, then one by one. So for that, again, I'll use the object of iterator dot next. So people generally use this kind of iterator to print the collection data because performance wise, iterator printing is faster compared to the for each loop. So this you can keep it in mind. Faster compared to for each. If at all, whenever you want to display correct data or you want to do some more operation while iterating, while displaying, you can use iterator object. So in coming topics, I'll tell you more about iterator, how it is useful in while iterating if you want to modify the collection data. So on what situations we have to use this iterator, I'll give much more clarity. But as of now, remember, if you want to display any collection frame of data, this is the normal way of doing it using for each loop. Alternative way is using iterator. So if you use this, it is faster compared to your for each loop. Okay. So let me create one more class. So what we learned till now is how to create a hash set, how to convert the hash set into array and then sort it. And without doing all this, how to sort it using TreeSet. Internally, we will be doing that internal sorting. For the better clarity. Create hash set using the collection framework hash set. Try to do a few more operations. Suppose if you have 2, 3 asset to work with, your program. So I'm creating one more asset here. Right. So I created 2 assets, separate object. So if I want to do some more operations using this, suppose I want to combine these 2 assets, right? So what I'll do is I will use the inbuilt function called as retain all. Let's try to display the set1 object data. So what is that you are getting the output? You are only getting the 100 as the output. So you can see the reason. What is the job of this retain all function? So it retains only the elements in the collection that are contained in the specific collection, right? So whichever the elements that are common in both the sets, right, that will be retained by this particular function. So true if the collection changes as a result of the call, right? So retains only the elements in this collection that are contained in the specific collection. So the common elements it is retaining. So let me add one more element here. For example, I'll add 40. Try to rerun this. 40 and printing. So the common elements we are filtering out. So these kind of functions you can explore the supporting function. So any collection that you are learning, so your job is to list down the useful functions or methods supported by that particular collection, right? Collection framework. So only when you have clarity on those functions or the methods, you'll be able to apply in your logic. So that is the first step, right? We should know what is supported in those collection, how to apply them based on our necessity. So there's one more way which I wanted to tell you. The concept of linked HashSet also, or linked list basically. So linked list I can create. I'll talk more about linked list in the coming topics. So as of now, just concentrate on whatever I'm typing. So I can convert that the set one object into linked list, right? One more way of ordering the data, either in ascending order or descending order. So then what I'll do is I'll apply the iterator. So we have to import that iterator. Okay. For this particular hash set, linked list which we created for the hash set, you can see already I'm getting the suggestions. So if I want to sort out the data in the descending order, you can do like this also. So while iterator dot as next, I want to print each element. So will you print each element? Iterator dot next. In the descending order, right? So you can either sort in ascending order or descending order using iterator also. So if you don't want to convert that into array list and convert it into two array and all, so this is one more way. So first thing that you have to do is convert that hash set into linked list. Then that linked list object, I have to apply the iterator object for that linked list object, which is LSet. So we're creating the iterator object for that LSet. Then using that iterator object, we are printing them in the descending order based on this function. So a lot of such methods are supported by the iterator. So what else we can do using, right? So we can split, we can just access them. We can modify the data, right? So we can combine one, linked list data to another linked list data. All these things we can do using iterator object. So it has a lot of functionality, which we will be exploring. Okay. So this is about basics of HashSet, which you are seeing. Let me continue with the next question that I wanted to discuss is, we'll see in detail about iterator, why we require iterator advantages. Okay. So first create an integer list. Sorry. Okay. So what is the advantage of iterator is generally when we display using for each, we can't modify we can't modify the data, right? Collection data. But using the iterator, what we can do is using the iterator while accessing only, we can do operations, right? Basically, we can filter out the data that we don't want, right? Basically, filtration we can do, customized output we can print. This and all we can do using iterator. So how we can do this? Let's see. So let's create an iterator object for our array list. So iterator integer. So give the name for the iterator. Like create the iterator object, use the integer list object, that is numbers, right? The numbers dot iterator. So we created the iterator object for that array list, right? So after doing this, I want to access the data using the iterator object, iterator dot as next. Now I don't want to directly print using s out. Suppose I'll add few more numbers. Right? So few more numbers have added. So what I want to do is I want to fetch the next element from the array list. So I'll take one more variable int current equal to, using the iterator object, I will fetch it. So basically what does this next will do is fetch the each element of the correction framework, right? So what I'm doing is accessing that value and storing it in the current variable. So after this, what I want to do is I want to only print those elements which are dot remove. So basically what I want to do is, if there is a number in our array list which is divisible by 2, that number I want to remove. So we are removing while printing basically. So basically we're filtering out the all even elements from the array list, right? So if any such even number comes in the array list, that number we are removing using iterator.remove. So this functionality, we can't do it while fetching the data from the normal collections using for each loop. So this is allowed and possible only using iterator. So that is one of the main advantage of using the iterator, right? So then in the next line, what I'll print is after the for loop, I'll print the data. So as you can see in the output, only 5 and 33 I'm getting in the output because so this iterator object has removed all the even elements. So this kind of modification is possible using iterator object. Alternatively, if you don't want to do like this, the session I told you about the lambda expressions, right? We can use lambda expressions to do this particular task, right? So what we can do is create a list. For example, I'll make the name as odd numbers, list integer equal to odd. Then what I'll do is I'll use the object of array list numbers dot, I will use stream function, stream method. Then for the stream method, we will use filter method. Right? So this I already discussed once. Here I can write the code. So this is the format for the lambda expression. N indicates the parameter and n mod 2 indicates the body of the lambda expression. So this left side parameter after the arrow mark, this is the body of the lambda expression. So n dot filter n mod 2 not equal to 0. Basically, I want all the odd numbers, right? So it only collects all the odd numbers means I have to check not equal to 0. After that, again, I will collect all the data using dot collect collectors dot to list. So this entire thing can be done on a single line using lambda expression. Now I'll print that odd object. You will see whether we will get or not. You can see on the output screen. So the same output I'm getting using the single line. But again, though it is doing this entire process in single line, if you talk about performance, still iterator is better. Here the reason is, again, here we are to do all this process, we have to use this collectors framework, right? And we are creating one more list of integer values. So we are creating extra memory space to collect the data. So which takes more memory space, and this might be an issue if there is such constraint. So better ways to filter out the data is using iterator only. So all these mechanisms depends on the requirement and the constraint. So whatever is supporting for your logic, that you can use, right? So this is one another way. And what is that I told is, you can also put them in the separate line. So numbers dot string dot filter dot collect. So this is also possible. So such methods you should know. And internally, your enhanced loop will also follow the iterator only, right? So in general, right, when to use the iterator, if there are large collection of data, then iterator provides better efficiency, right, compared to dices and regular loop printing, right? It also avoids creation of additional copy for collecting the additional copy of list for collecting the data, collecting the filter data, right? So this is what we need to remember. So if someone asks why to use iterator, means for larger collection of data set, iterator provides better memory efficiency, and it avoids unnecessary creation of the another list to store the data, the filter data that we are fetching. So this one thing, please remember, if there is a memory constraint, always try to do the logic using iterator. Okay, just to do whatever I'm discussing. Right. So we'll go to the next one. Already I told you what is the need of TreeSet over HashSet and TreeSet is TreeSet arranges the data in their natural order, correct? That means it sorts them in the ascending order by default. So let us do some more operations on the TreeSet. Okay, so this is how we need to create the TreeSet object. Then to add the element, how will you add? TreeSet dot add, same like HashSet. So I'll duplicate this line. Add some random elements. Okay. Here I've created the TreeSet, added few elements into it. Suppose if I want to display the reverse data, since you know already that TreeSet prints the data in the ascending order. Let's see whether it prints or not. Set. I want to display the data in the reverse order, reverse TreeSet. So use the TreeSet object, TreeSet dot. So there is an for that doing the descending set. Okay. So you can use this descending set internally. It will filter out the data in the descending order. Right. So you can see thing cannot be done using HashSet. So I'll be discussing some important methods supported by TreeSet. So these are the very important basic methods whenever you want to use the TreeSet. Build methods basically. Build methods supported by TreeSet. Okay. So let's see them one by one. So what I want to do is just keep observing. So I'll use the object of TreeSet. TreeSet. Right. So a lot of sub methods supports TreeSet. So I'll use here one of the method called as headset. Okay. So headset, what does it do? We'll see. Right. Do headset. It returns the view of the portion of the set whose elements are less than to the element that is passed to it. Okay. So we have to pass some number to this headset. So I'll pass some number to it. So for example, I'm passing 24. Okay. Let's run this. What is the output I'm getting on the screen is 3, 12, 15. And that also in the ascending order. So what does this headset is helping us to do is, it is filtering out all those numbers which are less than that particular number which is passed to it. That is 24. Suppose I want to include that 24 in the output. You can just pass second parameter to it, true or false. So along with the 24, I'm passing true to that headset. Okay. So you can see in the output screen 3, 12, 15, 24. I'm getting as the sorted data up to that particular point. So lesser and equal to that passed number. So you can pass the second parameter. It is optional. And if you don't want to include that, just don't use that particular parameter. Just pass the number. So the second parameter is optional, right? So parameters, you can read 2 element, including that particular value. So similarly, a lot of such inbuilt methods can be helpful when we do the problem solving using TreeSet. Okay. So there is one more right. If I want to extract certain values from the TreeSet, so I'll use the object name, and here there is a function called a subset, so for which you have to pass some values, right? So what does the subset do, right? So it returns a view of the portion of the set whose element range from the from element to element, basically from 3 to 15. If there are any numbers that we want to fetch it, right? So let's try to print them. See, we are displaying all the numbers that are within the range from 3 to 50, including 3, excluding 50. Suppose if you want to exclude 3, again you can pass false to it. For 50, you can include true. This 50 is not available, so we are not getting 50 on the screen. Suppose if I have 50 on the output, TreeSet dot add 50. So let me add 50 into the HashSet and in TreeSet. You can see the output. I am getting 12, 15, 24, and 50, including 50, right? So you can pass these optional parameters, true or false conditions. So If you mention true here, 3 also will be included in the output. If you mention false here, 50 won't be included in the output. So we are fetching the subset of numbers within that particular given range. That is subset function. Similarly, we have something called as tail set, right? So tail set. So I can use tset dot tail set, right? Particular function return. So if you observe, it returns a view of the portion of the set whose elements are greater than or equal to that particular from element, right? So all those elements that are greater than 15 are only appearing there. 15, 24, 50, 66, and 100, including 15. And 3 is excluded. We are not printing 3 on the screen, right? So that will be achieved by tail set. So head set, subset, tail set, all these are part of the TreeSet library. Similarly, this is about fetching the data, right? All these things are methods are useful for retrieving the data, right? You want to retrieve the data. Similarly, if you talk about removing, so for removing also we have some library files for doing that particular application, right? Suppose if you want to fetch the maximum element, maximum value from the TreeSet. So you know by default TreeSet already sorts the data in the ascending order. So let me try to use this method. So poll first. So P small letter F capital. So what does this poll first do? Retrieves and removes. So it is not only retrieving, it is also removing from the TreeSet. So retrieves the first element or returns the null if the set is empty, basically. So basically we are removing the lowest element, not the maximum element, the lowest element. Okay. Right. So we are getting the output as 3. So by default, it always fetches the least value. Similarly, you can fetch the maximum value from the tree set using tset dot poll last. So this is a method poll last. This will fetch the maximum value from the given tree set. Okay, so we are getting the maximum value as 100 here because that 100 is the maximum value in our tree set, right? So we should have awareness about all these methods while doing the problem solving and use them accordingly in our logics, right? And similarly, if you want to display the reversed, I already told you, directly you can use tset dot descending set, right? Or if you want to store the data, so I'll show you one more mechanism. Suppose if I want to create more set, so what I'll use is I'll use the comparator. So while creating the tree set only, what I want to do is the data has to be by default stored in the reverse order. Correct. So let me see. Now what I will do is reverse set method I will use. I mean the object of reverse set. Then I will use the add all method. Then whatever the data that was there in our main tree set, I'm adding into this particular reverse set tree set, right? So what we did here is for this next new tree set, we are adding all the elements of tree set, the original tree set, right? Then let's try to print our the second TreeSet data, which is reverse set. You will see whether we got the data in the descending order or not. Data is coming in the descending order, but 3 and 100 are removed because we are also deleting from the tree set, right? So here the advantage is we are not altering the original tree set. Original tree set is as it is, but we are copying that original tree set content into another tree set. Then while copying only, we are doing the reverse order, right? So for that, what is that collection framework we are using? Comparator. So comparator is very powerful again, right? For that, we need to use this library file. So comparator dot reverse order. So while copying itself, it stores the data in the descending order. So here we are efficiently doing the conversion. Here what we did is we use the another library file. So this takes additional memory, right? Because first I have to create the data, add them into tree set, then I am doing the reversing. But in this mechanism, what we did is while creating itself, we are reversing the data. So compared to the that particular way of doing the reverse of the data, here we are doing it efficiently. So there are a lot of mechanisms in Java. We can use them based on our requirement, right? So it is not one way, multiple ways we should know. And there's one more important point you should remember compared to the HashSet. So which I will tell you now. For example, we'll go to our HashSet add. Let me print here only. So not here. I'll add to the first set here. Set one dot add none. So our original set. So as you can see, the original set, we can also add null values. Suppose if I don't have any value to store, we can store null values in our original set. Let me try to add one more null value. Okay. So as you can observe, our set, no matter how many times you add null values here, it is only displaying the null value only once, right? So basically, if you don't have any data, you can add null to the set. No matter how many times you write it, it only stores once. So basically, a hash set allows the null values, right? So hash set allows the null values, but a single null value, right? We'll just try to do this in our reset here. Whether we can able to do it or not, similar to our asset, we will check. Suppose I want to add here reset dot add null. I'm getting an error here. So the main important difference should understand is reset doesn't support storing null values. So if at all you want to store some null values or print null values using TreeSet, that is not allowed. Okay. So basically the TreeSet is a natural ordering. That means you should have some elements to put them in the ascending or descending order, right? Or in the alphabetical order. So whenever you don't have a data in TreeSet and try to add null to it, then it doesn't support it. So we have to be very careful when we are doing the operations. TreeSet doesn't support the null values. So this point, please keep it in mind. So I'll write here. The data to store them in natural order, right? TreeSet requires one or the other data to put them in the natural order, and null doesn't have any natural order. Null means it's empty data, right? So we can't store null in our TreeSet. Even though if you write it also, when you execute, you will face the problem. So without null, we don't face any problem, right? Okay. So in TreeSet, what we learned? We learned how to reverse the TreeSet. This is one mechanism, right? And we learned how to use the inbuilt method supported by TreeSet, and whatever the methods that we used for retrieving the data, right? So for retrieving the data, we have head set, subset, and tail set. For removing the data, we have poll first and poll last, right? Removing and fetching the value, both it will do. And similarly, alternative way for reversing is add that particular hash set into another hash set, another tree set, sorry, and pass that comparator dot reverse order to it. So while adding itself, it filters out the data and puts them in the descending order. So this is the some of the important methods and how to use the TreeSet basics that everyone should know. So moving on to the next one. Similarly, we have one more collection framework that is called as LinkedList. Very important and very useful for your problem solving. So you can mark it as important, right? So how to create linked list? So there is a difference between array list and linked list. As you know already, we learned linked list in C language. So similarly in Java, how can we create a linked list using our collection framework, right? So linked list object we have to create. So I'll use the object name as LList, new linked list. And let's add some elements. So I've added some elements into the linked list. Let's display the elements of the linked list directly. So if you see the difference between our tree set and linked list is it inserts the data in their original order. That means in the iteration order, whatever the element I'm inserting in that left to right order, the elements are inserted. The first element is 5, second element is 55, 51, 15, and 25. In that order, the data is getting added. So this is natural ordering, right? Suppose I don't want to follow this natural ordering. There are again supported methods to insert based on our requirement, right? Based on our requirement. So object name is a list. So you can see linked list supports a lot of methods. As you can see, it is already suggesting the IntelliJ. So for example, I want to add the element at first position, right? And for this, you have to pass the value. So for example, I'll pass 54. Similarly, I want to add the element at last position. So add first, add last. So insert the specified element at the beginning of the linked list, right? So let's print the data. So 54 is added in the first position, 100 is added in the last position. So here we are customizing our insertion. So add first and add last, right? So LinkedIn support a lot of such methods. Suppose if you want to add somewhere in the middle, insert in the middle, right? Somewhere based on the position, based on the, for that, what you can do, you can still customize your add method. So add is, LinkedIn supports two add methods. One is directly insert based on the number, another is based on the index. So here you can mention the index position. For example, I will mention the index position as 4, and for example, 345 is my value. But if I inserted here at the fourth position, so 0, 1, 2, 3, 4. So at the fourth position, I'm inserting. So basically, we are simplifying our linked list using this collection frameworks, right? Similarly, if you want to fetch element at the particular index, suppose if I want to check what is the element at the index 2, you can use list dot, sorry, list dot get. So 55. So here again, we are doing the accessing job here, right? How to access the elements based on our requirement. Suppose if I want to replace, right? So replace the existing element. For that, again, we have a list dot set. Here you can see how to pass the index, the element which you want to replace, and from which element you want to replace. So index position and the replacing value. Suppose I want to replace the element at 6th index with something else, for example, 670. Okay. So you can see the 6th element is replaced with, the element at 6th position is replaced with 670, 0, 1, 2, 3, 4, 5, 6. So there are a lot of helpful such functions which you can utilize. Inserting and fetching and updating, right? Similarly, how will you delete, remove operations? So for removing also, we have a lot of support and method. So let me first use remove, right? So retrieves and removes the head of the list. So if I just use remove, let's see what happens. If what was our first element? 5 was our first element, right? Print our linked list before removing. What is our head of the linked list? 54, right? So after removing the head of the list, right? This is our updated list. Just mention remove method. It will remove the first element of the linked list. That you can still customize. Suppose I will write a list. Will comment like this: a list dot remove first, right? So both of them are doing the same work, right? Removes and returns the first element, right? So either you can use just remove or remove first. Both of them are doing the same job. Similarly, if I use a list dot remove last element of the linked list. Okay, so you see 100 is deleted. Suppose if you don't want to remove directly and if you want to remove based on the position, or sorry, not based on the position, based on the element value, right? So based on the direct value, if you want to remove, how to do that? For that, again, you can use list dot remove. In that, you can mention the object name. For that, first you need to convert, because it's a collection object. You have to convert that into integer object. Integer dot value of you have to use. And suppose if I want to remove 345 from the list that is here, so you can customize your remove method. List dot remove integer dot value of 345. So this will remove the specific element that we have mentioned. 45 is removed from the list. So your job is to learn these basics, explore what are the supported operations, how can we use them, right? Then if you want to do the searching, so you already know how to search the collection framework using contains. So you can directly apply that. Suppose if list dot contains, I can use contains method. I'll check whether 15 exists in our list. Okay, so I'm getting true as the output here because 15 is there in the list. So we're getting the output as Boolean value. So contains method will return the Boolean value true or false. Suppose what if there are, suppose I'll add some element which is 5. So as you can see, after adding 5, we have 2 copies of 5, one in the beginning, one in the end, right? So now if I want to delete 5, I have to be specific about which 5 I want to delete, right? So to do that also, we can have a method remove first occurrence or last occurrence. So this library files you can use. Remove first occurrence. If I mention remove first occurrence, you can pass that remove first occurrence. So inside that you have to pass which value you want to remove. So as you can see, after updating, the last 5 is as it is, first 5 is deleted. So this is for duplicated data, which element you want to particularly delete, right? Similarly, you can apply one more method, very important method, that is, so the method name is remove if. Yeah. So list dot remove if. So here I can mention the condition. I want to remove the elements only based on certain condition, right? So here it basically works on the principles of lambda expression. So I have to use this parameter. So remove if. You can just highlight over it. It will give you the exact representation how to use it. So removes all of the elements of this particular collection if that satisfy the given predicate. So we call it as a predicate or lambda expression also you can call it. So n is the parameter and n mod 2 equal to 0. So here again, I want to remove the elements from the linked list only if it satisfies this particular condition. So what is the condition is? It should be divisible by 2. That means I'm removing all the even elements from the list, right? All the odd elements are left out. Only the even elements are removed, correct? We can customize our, deleting operation also based on our requirement. Then as usual, if you want to check the empty condition, you can use the is empty. And if you want to clear the entire linked list, you can use clear method. Okay, so after clearing, you are seeing the empty linked list. That's everyone should be aware of before doing the problem solving, right? So you can utilize them as and when required. So I have almost covered 80 to 90%, whatever the methods that you require in general for problem solving. Apart from this, you may not require other advanced library files, but these are the most basics one which you need in your problem solving whenever you use this particular collection framework, right? So last one that I want to discuss for today's session is, let's apply this concept to whatever we learned on real time. For example, so let's create a class. What I want to create the class name as, okay. I have created the class name as TreeSet cricketers. Now let me create one more class for this. Class cricketer. So inside that, I want to have some number variables. So I'm creating these member variables. And as I explained in the last session, how to create the constructor, you can use Alt Insert button, select all the parameters, click OK. So you'll get the constructor ready for you, right? So just keep observing how we can apply these concepts in real time. Okay. So what I want to do is, I want to sort out the data of the cricketers based on the runs scored, for example. So I want to implement this comparable class, right? So you know the implements keyword in Java. So which is nothing but used to, what does we use for implement keyword? Implement keyword is used for what? Implementing the interface, right? So here interface name is comparable, and this comparable I want to apply on the cricketer class, right? And if you want to implement this particular comparable, you see why the error is coming. Class cricketer must either be declared as abstract or implement abstract method compare to. So compulsorily we have to use this compare to method in our program, right? So you can see it automatically generated compare to. Now we can customize this compare to method based on our requirement, correct? So let's customize this. Basically what I want to do is, before applying our logic on this compare to, first let us create the data for the cricketers, right? So we have one more class here, main class, inside which I want to create the tree set. Now what I want to do is, I want to apply this tree set on the cricketer class, right? So the object name I'll give it as cricketers equal to new tree set. So we are storing the cricketer objects into this tree set, right? Then let us add our data, cricketers dot add. So for adding, what we require, or basically we have to create the object, right? So cricketers dot add. Before adding, what we have to do, we have to initialize the players, right? So cricketer c1 equal to new cricketer. Here I have to pass the player, right? For example, so what is the order in which I have to pass? Name, age, and runs. In that order only we have to pass. Suppose runs scored at 12,000. Similarly, I'll create create one more cricketer object, C2, new cricketer. Here I'll pass the name of the player. So runs code, I'll put 7,000. Okay. One more. So what we did here is we created the cricketer object C1, C2, C3, and we initialize those player names, right? So after doing this, let's add them into our tree set. So one by one. So I'll add C1, then add the object 2, that is C2. So basically C1 means I'm not just adding the one value, I'm adding all these values into our tree set, correct? So player name, age, and the runs code all are getting added into our tree set. Then cricketers dot add C3. So all the data are added into our tree set. So before continuing our operations, let's see whether we have added now successfully. So what is the object name? Cricketers, right? Okay. So as I told you in the last session, if you directly print that objects of the class, you will get this hash value. Can anyone tell me how to print the values? So we have to use toString method, right? Here I want to print the data using toString. So here, this is the internal representation. If you want to customize this, still you can do it. Suppose I want to customize this based on my requirement. I want to print simple way, name equal to name of the player, parameter that I have to pass. Then after name, what I want is, I want a space between the scores, right? Then I just want to print the runs score. I don't want to print the age. So runs score is equal to. So here what I want to pass is the member names runs. So what does this toString will help me to do is, it will only print name and runs code whenever I call this cricketer object. So let's run this. We can observe only one player data is added, right? That is Virat Kohli. So what is the problem here? After creating the object, first we need to add them, then go for the next object, right? So cricketers dot add, immediately this line has to come here, and this line here, and this is as it is. Till the data is not getting added. Let me check where is the error. We have the instructor ready. This for loop, whether it is anyone. Check. Using for loop, I will print and type is cricketer class. Object name will use as CR. Let me just print whether create a getter method here. So I will create the getter method. I will insert. Suppose I want to just print the runs code. So get runs, right? So I will call get runs here. And each of them should be separated by space. New image, new line. So only one data is getting added. Just 2 more minutes. It was so the reason you need to understand is we have not yet implemented this compare to, right? So what I wanted to do here is as and when the data is getting added, each element should be compared to other element, and we have to return the data one by one. Since we have not completed this compare to, so we are only just getting the one value. That is the first value that we have added. So our next step should be completing this compare to, right? We have to customize this compare to function. So whenever we are adding the data into the tree set, every element should be compared with each other, and they should be stored in some order. So for that, what you want to do is use if condition. So since I want to sort the data based on the runs, right? So if this dot runs is less than O dot run, basically O is the object that is coming every time I'm creating the object here. So if this dot runs is less than O dot runs, I want to return -1, and if else otherwise I want to go for else if dot runs is greater than O dot runs. Okay, so if it is true, I want to return 1, right? So if above both of the above conditions are false, means I want to return 0. So we are customizing our compare to function. So every time I create an object, each object gets compared to other object only with the runs, right? Okay. Now you can see our data is getting printed in the ascending order of the runs. For example, I'll put new line here. The first data that we are getting is name Rohit, runs code is 7,000. Again, name Pujara, runs code is 9,000, and Virat. So here we are not actually doing any sorting manually. Everything is taken care internally by this compare to function. So that is whenever creating the object of our tree set, the next object gets compared to the first object. Here see 12,000 gets compared to 7,000. So if the current object is less than the o dot runs, that is next object, we will return -1, right? Then otherwise, if this condition is false, if this dot runs is greater than o dot runs, so we'll return 1, right? So for the first two objects, this else if condition becomes true, so they get internally exchanged. So each object is getting compared with other element whenever we are adding the data into the tree set. Suppose if you don't want to do this manually, all this approach, to do this internal sorting also, we have an inbuilt function. Okay. So what we can do is, since we are applying on the runs, we have to use integer dot compare. So there is a compare function. So each element I want to compare as and when they are added. So what I want to compare runs, right? So I want to compare this dot runs with o dot runs. What we did here, that will be internally done by this compare function. So you see the same output. Suppose I want to sort it based on the age. So this dot age, comma, o dot age. Right. So at this particular stage, you are saying Virat first, Rohit second, Pujara third, because we are sorting it based on the age. Suppose I'll add Pujara second. Right. Still you are getting the Pujara in the end because the sorting is happening based on the age parameter. So this is the importance of tree set. Basically, we are implementing the interface called as comparable. On which class we are applying that? On the cricketer class, right? Then we initialize the data using the constructor. This is for printing the data. This is for just printing the get runs, and this is for actually sorting it based on our requirement. Suppose I want to sort it based on name, I can pass name here, age or transport. Here we are creating the object of tree set and adding each element into the tree set, right? Then we are printing them one by one. Suppose if you don't want to do this, if you want to just display the runs, you can do that also. So the runs are displayed based on the order in which you have inserted. Here, sorting is not applied because sorting is applied only on age, and what we are printing here is based on the runs. So if you want to print all the elements, whether they are sorted in based on our requirement, you can print the entire object. So this is how you can use the tree set and any other collection based on your requirement and see how they perform, right? So we'll be exploring and learning a lot of such other examples based on other collection frameworks. So two more collection frameworks are pending. So I'll discuss them in the next session. Don't miss that. HashMap and TreeMap. Okay. Both of them are similar again. So you should know the main difference between HashMap and TreeMap and when to use them. So we'll try to solve one or two problems based on HashMap and TreeMap in the next session. Okay. So collection framework is very powerful. You need to know in and out of that to apply on the problems that you are going to solve in future. So for that, your basic foundation is very important. Please give attention to understand the syntactical rules. Whenever you get error, see what is the reason you are getting those errors, and immediately you should identify where is the error, right? That's the proper learning. So I'll see you in the next session, that is on Monday. Monday, Wednesday, and Thursday. So 3 more sessions are pending. We'll try to cover the remaining topics in the next 3 sessions. See you in the next session. Thank you.